Hello, welcome to LearnWise Academy. Today we'll be focusing on Math 101 and we'll be looking at the topic called Set Theorem. Set Theorem, that's a popular topic in mathematics. And according to our normal definition, a set can be defined as a collection of a well-defined object. A set can be defined as a collection of a well-defined object. Now, what is this trying to say? Now, breaking this down to a layman understanding, we notice that sets are always the collection, not only the collection of a well-defined object, but a collection of a well-defined objects that have similar peculiarity or similar characters. Is it that similar peculiarity, or you can use characters, depend, which means that a set must be connected, which means that for something to be called a set, it must be connected. So according to the definition we have here, we have that a set is a collection of well-defined objects. And just for in case of those writing exam, you know that nobody, no lecturer or no teacher will ask you the definition of a set. So the definition of a set is very important, though it's important, but it's important because of mathematical purpose. For those going further in maths, for you to know the definition of sets, you understand? For you to better understand sets, you need to know the definition. But it doesn't mean necessarily that they will ask you the definition of a set in your exams, in your various exams, whether you're in secondary school or you're in university, you still encounter sets. Now, there is a thing I would like us to note. If you watch according to what you're seeing in the video, I would like us to note that the items that make up a set are called elements/members of the set. Now, those items that are meant to be peculiar or they are meant to have similar characters, they are called elements of a set or members of a set. Elements of a set or members of a set. Elements of a set or members of a set. Now, it can be denoted with E. It can be denoted with E. Now, we'll run another video on the signs that are involved in sets. Signs that are involved in set operations. So why I didn't go further to indicate the sign is because we'll still run a video on the signs that are involved in set theory. Now we have an example of sets. Example of set number one example we have is a set of natural numbers. A set of natural numbers. Now if you watch at the example, a set of natural numbers, we have A is equal to 1, 2, 3, 4, 5. Now, what are natural numbers? Natural numbers are just your normal numbers. Something like 1, 2, 3, 4, 5, 6, 7. Those are natural numbers. They are just your normal numbers. Now, we have number two example. And note, please note, that a set must begin with a capital letter. If you watch, I began my set with a capital letter, which is capital letter A is equal to 1, 2, 3, 4, 5. A set must begin with a capital letter. So that's the rule. Now we have the second one, a set of even numbers. A set of even numbers. Some example might say a set of all even numbers. It depends. So we have a set of what? Even numbers, which is y is equal to 2, 4, 6, 8, 10. Our primary school definition of even numbers. Even numbers are numbers that can be divided by 2. Even numbers are numbers that can be divided by 2. Now we have the third example. The third example says a set of vowels. A set of vowels. A set of vowels. Which is that X is equal to, of course, we know our vowel sounds in English, which are A, E, I, O, U. That's our vowel sounds in English. So these are example of a set. This is how sets look like. Now, from what I said in the beginning, that they must have similar characteristics or peculiarity, is that if you watch, they are obeying the same rule. If you watch a set of even numbers, you observe that the set is made up of even numbers. Had it been I saw something like 2, 3, 4, 6, 5, it's no longer a set of even numbers. It has changed from a set of even numbers to a set of natural numbers. You understand? So for something to be a set, for something to be a particular, for something to be called a set, it must have what? Similar characteristics or what? Peculiarity. If you watch the third one said a set of what? Vowels. A set of vowels where we have that X is equal to A, E, I, O, U. You understand? We are listing only vowel. Had even I included consonant sound here, it makes X not a set. X will no longer be a set because I've included what? Vowel sounds. I've included vowel sound. Now the next thing we're going to be looking at is set notation. Set notation. Set notation can also be called set representation. It can also be called set representation. And we say that any given set can be represented in two forms. Any given set can be represented in two forms. Any given set must be represented in two forms. And the number one forms we have is by listing / roster method. Is that you call it by listing or you call it by what? Roster method. Is that you call it by listing or you call it by roster method. Now, what is by list? What's sets? When a set is listed by listing method or by roster method, what does it mean? It means that this okay, according to the definition of listing method says that this involves listing all the elements of a given set explicitly. Listing all the elements of a given set explicitly. Now, what does it mean to list something explicitly? It means that, watch, if you have the second example here, that X is equal to 1, 2, 3, 4, 5. We just listed it normally. Explicitly means just accordingly. It means accordingly, that like listing a set accordingly or listing a set normally. You can just use normal for a layman understanding. You can use listing a set normally. Now we have the second one. Okay, the first example of listing method, we have that X is equal to x1, x2, x3 up to xn. Listing method or roster method simply involves listing. Just list it out. Something like a set of what? All the mountains in Africa. You can start by Mount Kilimanjaro and the rest of them. You understand? You start listing them. You are listing them one after the other. That's what it means to list what? Explicitly. And that's what it means to what? To list by roster method. Number two, we have what we call by set builders method / specifier method. By set builders method / specifier method. When I say that this involves representing a given set by proper description of the property that are possessed by its members / elements. It involves representing a given set by a proper description. Please take note of the word proper description. This proper description well explained set builders method. This involves representing a given set by proper description of the property that are possessed by its members / elements. By its members / elements. So now, in order to explain set builders method, we have an example. Let me use an example to explain it. We have an example that A is equal to x. A is equal to x such that x is odd and x is greater than 0 and less than what? 12. A is equal to x. This column here means such that. Whenever you see column, there are some signs in mathematics that we ought to take care of, like we ought to take note of. Sorry, there are some signs in mathematics we have to be conversant with. Something like column. Column means such that. And like I said before, we'll be releasing a video on the signs you need to take notes in sets. All the signs you need to take notes in sets. And this example says that A is equal to x such that x is odd and x is greater than 0 and less than 12. X is odd and x is greater than 0 and less than 12. Now, what does this mean? This simply means that the set A comprises of all numbers, all odd numbers, because they said x, A is equal to x, and x are what? All odd numbers. X are what? All odd numbers. That means x is odd. That means all the numbers involved, all the numbers that are inside x are odd, and x is greater than 0 and less than what? 12. X is greater than 0 and less than 12. That means all odd numbers that are greater than 0 and less than 12. Now, what are those odd numbers? We have 1, 3, 5, 7, 1, 3, 5, 7, and the last one should be 11. Yeah, so we won't get to 12 because 12 is not an odd number. So it's what? 1, 3, 5, 7, and 11. You understand? Because the question says that A is equal to X, such that X is odd and X is greater than 0 and less than what? 12. That means X is what? Less than 12. That means wherever we stop, the number there should be what? Less than 12. So that's the concept. So now we'll be proceeding to the next one, which is types of sets. Types of sets. Alright, next up, types of sets. Now there are up to 7 types of sets, but due to the length of the video, I'm going to be giving out 5. Or moreover, let's see how the video goes. Now we have the first type of set. We have empty/null set. Empty/null set. Now empty/null set can be denoted by finc or an empty curly bracket. It can be denoted by what? Finc or an empty curly bracket. Now what is an empty set? Empty sets are said to be those sets that has no elements in them. Empty sets are sets that has no elements in them. Just like the name sounds, empty or null. When something is null, it means it's empty. It's denoted by finc or an empty curly bracket. Now the second one we have is singleton. Singleton set. A singleton set. A singleton set. Just like empty set is defined as element that has no elements in them. Set that has no elements in them. A singleton set can be defined as a set that has only one element. Just like the example here, A is equal to 8 and X. Set A is equal to 8 and set X is equal to small letter x. Singleton sets are sets that has only one element. Has only one element. Now the third one we have finite and non-finite sets. Finite and non-finite sets. Now what are finite sets? Finite, just like the word sounds, finite. Finite sets are sets which the elements are countable. Finite sets are those sets that their elements are countable. Finite sets are those sets that their elements or members are countable. Example of a finite set, we have a set of all states in Nigeria. If you watch, we have set of all states in Nigeria is 36, right? Set of all states in Nigeria. If you start listing them, it's 36 in number, which means is what? It's countable. Now we have the second one, a set of all 7 continents in the world. It's 7 already, that means it's also what? Countable. So whenever a set can be counted, that set is classified under what? Finite set. Whenever a set is countable, the set is classified under finite set. Now move over to the next one, which is non-finite set. Non-finite set. Now we see that a non-finite set is simply a set whose number of elements or members cannot be counted. A non-finite set is simply a set whose number of elements or members cannot be counted. Whose number is a set whose number of elements or members cannot be counted, which means you can't count a non-finite set. Example of a non-finite set, we have a set of all even numbers. We can't possibly count the set of all even numbers. Okay, we have here A is equal to curly bracket 2, 4, 6, 8, 10. Then you see those 3 dots. In English, we call it ellipses. And those 3 dots we call ellipses in English. It's used to show continuity. It means that it continues. It never finishes. You understand? It can't finish. It can't get finished. That's what it means. Now, these 2, 4, 6, 8, 10, which are set of all, we are actually as the set of all even numbers. We can't possibly do it because 1 million is an even number. 2 million is an even number. They can be divided by 2. That means it's an even number. So we can't possibly count them. We can't possibly count all of it. Now we have an example, second example, a set of all real numbers. This one is literal. It's clear that we can't count all real numbers. What are real numbers? Real numbers are numbers that are contained in the number line. Real numbers are those numbers that are contained in the number line. So we can't possibly count numbers from negative infinity to positive infinity. Just like I said, we used infinity, which means it cannot finish. It can't get to the end. So that's what it means. Now we have the third one, the fourth one, the fourth one, which is subsets and supersets. Subsets and supersets. Now we say that okay, let me use an example to explain subset and superset. Now we'll say given two sets A and B such that all given two sets A and B such that all the elements in B are contained in A, then B is called a subset of A, written as B. This is not C, this is a bent C, a closed C, like C that is very close, which the two mouths of the C are very close. That's B subset A. This is what it means. It means that B is a subset of what? A. Now, what does this statement simply is saying? Like, what this statement is simply saying is that if all the elements in B are contained in A, if all the elements in B are contained in A, it means that B is a subset of A. If all the elements in B are contained in A, it means that B is simply a subset of what? A. Now, since all the elements in B are contained in A and B is a subset of A, it simply means that A is now the superset of what? B. Now, watch out for the example I gave. Okay. Now look at this. Since according to what we have here, since B is a subset of A, then we can now say that what? A is called the superset of what? B, written as this. You know, superset, the sign for superset is backward C, backward bent C, backward bent C. So this is the sign for superset, backward bent C. That's the sign for superset. Now we'll move over to the next one. An example of a subset and a superset is A is equal to 2, 3, 4, 5 and B is equal to 3, 4. Now if you look closely, you observe that B is contained in A. There is 3 and 4 in B, and those 3 and 4 are contained in what? In A. Now this simply means that what? Therefore, it simply means that B is a subset of A. Sorry. B is a subset of A because B is contained in A. So it becomes the subset of A. Why A, which contains B, becomes the superset of what? Of B. That's just the concept. That's the concept. Now, if you have something like this, now if you watch, I wrote, but note, A is a subset of B, is a subset or equal to B. This is another example. It's not relating to the example. I'm just giving an instance. If A is a subset or equal to B, if A is a subset or equal to B, or B is a superset or equal to A. Now this dash under, this hyphen under means equal. It means it's a subset or equal to A. This one is a superset or equal to A. Now we'll now say that if it means that if A is a subset or equal to B and B is a superset or equal to A, this will be possible if every element of A is also an element in B. Now what do I mean? I mean that if for us to have that A is a subset and equal to B, so far this equality sign is here, it means that elements in A are also in B, which means regardless that they are both subsets, like this is a subset of this, they are also equal. It means that what? A is equal to B. That's just the simple definition. Now move over to the next one, which is proper sets. We say that proper sets, the notation A is a subset of B is an example of a proper set. It's called a proper subset. You can call it a proper subset, but proper subsets is just like this plain. There's no equality sign under. But if there's an equality sign under, it alters it. If there's an equality sign under. Now, if there's an equality sign, now watch what I wrote, which means that A is a subset or equal to B, but B is not. Sorry, this meant to be is not. But B is not a superset of A. What does it mean? It's not a superset or equal to A. What does it mean? It means that in this case, for something to be a proper subset, that A must not be equal to B. But here, A and B are equal because there's nothing like proper subset here. But if you want to attain your proper subset, it means that A and B cannot be equal. That means I cannot say that A is a subset of B, A is a subset or equal to B, and B is a superset or equal to A. I can't say that in proper sets. One of them must be greater. Like one of them is either B is bigger than A or A is bigger than B. One of them must be bigger. That's the concept of proper set. That's why it's like this. Proper sets. Now move over to the next one, equal sets. You know, of course, equal set is when both A and B have equal members, or equal elements. That's just the definition of equal set. Move over to the next one, universal set. Now, universal set, just like the name sounds, can be said to be the set of all sets. It can be said to be the set of what? All sets. That is a set containing other sets. Universal set, when we're going to start doing set notation, you understand what we mean by what? Universal set. A set that contains all other sets and is denoted by this sign. Something that looks like U but not U. This is a sign of what? Of universal set. Now next up, the next one we're going to have is H, which is the complement of a set. The complement of a set. And we said that the complement of a set A is the complement of a set A is a set that contains all the elements in the universal set but not in A. Now, this, you can understand this using an example. We have an example. Let U, remember I said this sign is universal set. When I say let the universal set be a set of what? A set of names which are Eze, Runke, Femi, and Sani. And A itself, this is a universal set, and this is A. And A itself be equal to Runke and Fumi, sorry. Now remember the definition says that the complement of a set A is a set that contains all the elements in the universal set but not in A. Take note of this not in A. It means that it contains all the elements that are in the universal set that are not in A, which means they are not common. It's not an intersection. They are not common. Now if you watch, I look for this A and this universal set. I simply look for the ones that are not common. The ones that are in the universal set. Runke and Fumi are contained in the universal set, just like the definition says. Runke and Fumi are contained in the universal set, but Runke and Fumi are contained in the universal set, but Eze and Sani are not contained in A. Runke and Fumi are in A and they are contained in the universal set, but Eze and Sani are in the universal set, but they are not in A. So since they are not in A, it becomes the complement of A. So now AC, which is A complement, A raised to power C, which is A complement, is equal to Eze and Sani, which means Eze and Sani is not common between the universal set and the what? And the set A. Now we have short formula. The short formula is simply, for you to get a complement of a set, you say A complement is equal to the universal set minus A. That means if I subtract the universal set, which is this, if I subtract the universal set, which is this, from A, I will get my A complement. And if I subtract it, I'll have Runke, subtract Runke, Runke is gone. Fumi, subtract Fumi, Fumi is gone. What's remaining? Eze and Sani. So this is just the short formula for what? Complement of a set. Now we have the next one, the next subheading. The next subheading is symbol of complement of a set. Now look at the symbols. Is that you use A, comma, that's A raised to power, your comma, or A raised to power C, or A inverse. Anyone. Is that you use these three. So these three is that you see, if you see any three of them in your various exam, it means that they're asking you to get the what? The complement of the set. Then the next up we have is what? Is power set. Power set, which might be the last type of set I will give. Power set, though we still have others, but this is the last I will give. Power set. Alright, power set. We said that power set, this is a set that contains all possible subsets of a given set. This is a set that contains all possible sets of a given set. An example, we said that power sets, it is denoted by what? Px. That's P. That's if you are looking for the power set of X, you have what? Px. That's the power set of what? X. And we say we have two ways of getting the power set. Two ways of what? Solving power sets. Two ways of solving power set or getting our power set. Number one is by formula method. Now we have the formula method, which is what? Pa is equal to what? 2 raised to power n. Now P, that's the power set of A, is equal to 2 raised to power n. Now what's the n? N simply represents the cardinality. Now if you're conversant with set, you will notice that cardinality means the number, like the number of elements in a set. Cardinality means the number of elements in a set. And let me take you back to this. Now let me use this as an example. What's the cardinality of A here? The cardinality of A here is simply what? 2. 2 is the cardinality of A here. Now why is it 2? Because there are only 2 elements in what? In set A, which is what? Runke and Fumi. And that's what we mean by what? Cardinality. Though we'll see in consequent time we'll see release a video on cardinality, or we'll do it moreover if time permits. Now we have the first one, which is what? By formula method, which is the power set of A is simply equal to what? 2 raised to power n. Now, if I'm asked to find the power set of a particular set, I get the cardinality of the set. Let me assume the cardinality of the set is 3. So it becomes 2 raised to power 3, which is what? 8. It means that the power set of that set is simply what? 8. Now we have number 2. Number 2 is by what? Is by subset arrangement method. By subset arrangement method. And let's give an example which will clear us in these power sets. Now this example says that find the power sets PA of A equal to 1, 2, 3. Find the power set of PA of A equal to 1, 2, 3, and the power set of PB of B equal to 1, 2, 3, 5. Now for us to solve this example, we are going to use 2 methods in solving this example. Is that we use the formula method, or we use by method of arrangement. So it depends on the one you are asked to use. Sometimes you might ask to use the arrangement method. Sometimes you might ask to use the formula method. All right, for us to resolve this example, which says that find the power set of what? The power set of P of A P, that's power set of A equal to 1, 2, 3, and the power set of what? Of B equal to 1, 2, 3, 5. Now let's get the power set of A. So by formula method, if you want to use formula method, that's PA, that's the power set of A by formula method, is simply equal to what? 2 raised to the power of what? 2 raised to the power of the cardinality. What's the cardinality of the set? The cardinality of the set we have here is simply what? We count the number of elements that A is having. 1, 2, 3. A is having what? 3 elements. So 2 raised to power what? 2 raised to power 3. And 2 raised to power 3 will simply give us what? Will simply give us 8. So therefore 8 is the what? Is the power set. That means P of A is simply equal to what? Is simply equal to 8. That's what we have. Now we'll get, if we try to solve this by arrangement method. Okay, let's try to get the power set of B using formula method too. So power set of B using formula method will be equal to what? 2 raised to power. What's the cardinality of B? We count the elements. 1, 2, 3, 4. So the element is what? Is 4 in number. So 2 raised to power 4. That's 2 times 2, 4. 4 times 2, 8. 8 times 2, what? 16. So therefore, we have that what? P of B is simply equal to what? 16. That's what we have as our answer. Now, if we want to solve, now I will solve the arrangement method of A. Then you will take the arrangement method of B as an assignment. You solve and submit at the comment box. Alright, for the sake of space, I decided to bring down the solving here, where we have solving the power set of A by arrangement method, where we have PA is equal to. Now how do I start this? I first of all bring the set out itself, which is A. A is the set, and after bringing out the set, I start making the set of A a subset of their own, which is what? 1. 1 is in the set of A. 1 is among the set of A. I make it a subset of itself. That's a singleton, which is 1. I make 2 a singleton. I make 3 a singleton too. This we have 1, 2, 3 now, plus the A, which is the set. That's 4. Now what do we do next? We start merging them, which is 1 and 2. We merge 1 and 2. That's where we have this. We merge 1 and 3. That's where we have this. And we merge 2 and 3. That's where we have this. And after merging them, what's the next move? The next move is to generalize. We generalize all these things, which is 1, 2, 3. Look at it here. Now if you watch, it's already complete. If you count 1, 2, 3, 4, 5, 6, 7, 8. And what's the definition? Remember, it's 8 here and it's also 8 here, which means our answer is correct. This proves that our answer is what? Well, correct. And now, How does this relate? If you watch, the definition of power set simply states that, watch the definition of power set. It simply says that this is a set that contains all possible subsets of a given what? Set. It contains all possible subsets of a given set. Now for set A, these are all the possible subsets of what? Of set A. These are all the possible subset of what? Of set A. Now they have what? 1, 2, 3, 4, 5, 6, 7, 8. They have 8 possible subsets in what? In set A. Now this is how to know you are correct. You just count and know if it's up to. You use the formula method to solve, then use this one to solve and count. If they are the same, they must be equal. If they are the same, that means you are correct. Now, for the sake of practice, I would have continued doing something like this. After generalizing everything, I would have continued doing something like this. I will remove 1 and I will have 2 and 3. I will bring it here. I will remove 2 and I will have 1 and 3. I will bring it here. And I will remove 3. I will have 1 and 2. I will bring it here. But I already have all these things. I already have it here. I already have, if I remove 1, I have 2 and 3. I already have 2 and 3 here. If I remove 2, I have 1 and 3. I already have 1 and 3 here. And if I remove 1, I already have 2 and 3. I already have it here. And you don't repeat a set. That's why I didn't bother doing that. You don't repeat a set. So you just close the set at this point. So that's just it. So if you watch, it's complete. It's 8 in number. This is how to solve using what? Arrangement method. Had it been, if I remove 1, I have something different than what I have here already, I would have continued. Remember, the power set is the possible number of what? Subsets of a particular set. That's the concept. So do the second one and leave your answer at the comment section. And if you are not yet at the group, drop your number at the comment section. We'll add you up to the group chat, LearnWise Academy. So thank you very much for watching. Kindly like, subscribe, and hit the notification bell so that you will get notified whenever we drop a new video, and also share to your friends. Thank you very much for watching.